Here is pre-calc. This is problem 1126. So it wants us to simplify, and we've got these two fractions. So I like to use a giant one to get a common denominator. So I did all that. So I want the common denominator to be x times x minus 1. So I multiplied the top fraction. Here, let's get it better. By x minus 1 over x minus 1. And then, so you can see I just rewrote this one. This one, x times x is x squared. And then I'm going to write, since they both have the same denominator, I'll just write them over one denominator. This I FOILed out, so x times x is x squared, and then the next two terms cancel out. And so this whole piece turns into x minus 1. And then this minus sign is just that minus sign right here. And then the x times x was x squared. And then these x squareds canceled out. And so I end up with this. And there's my final answer. So letter B, there might have been a faster way to do this, but I decided to turn this one into like a single fraction. So I wrote the 1 as y over y, and so that gave me x minus y over y. And then over here, I factored on the bottom. I saw that I could take an x and a y out, so I factored it, canceled up here. And this right here is a perfect square, or a difference of squares. So this, I rewrote this y squared minus x squared as y plus xy minus x. And I got some cancellations, and I ended up with x over y plus x. The next one was tricky. I had to look at the answer key because I was trying to do u substitution, but you have to factor something out, and so that's what was so hard, is figuring out what to factor out. So I'm just going to be honest, I looked in the answer key, and I've noticed by looking at the answer that they probably factored out a negative, or x to the negative 4/3, because that's the only way they would end up with a 1 right here. So the way I do this is, once I know what I'm going to factor out, I see down here I guess I should have known, because there's this term and this term are both the same, so you could factor it out and then it would cancel. So maybe I should have just noticed that right away. But so this is really 3/3. You know what I mean? So, and you know how when you multiply, you add to the exponents. So I'm just checking to make sure that it ends up to be negative 1/3, and it does. And then x to the negative 4/3 times 1 gives me back my x to the negative 4/3. And I even did some little work down here. I said 4/3 plus something equals negative 1/3. Oh, this is negative 4/3, sorry. And I ended up with 3/3, and that's how I knew that my exponent had to be 3/3, which is just 1. I didn't show it there. And then, so I factored out on the bottom negative 4/3. Hopefully you can see that that's going to equal 1, because if I multiply it back out, I get my negative 4/3. And then this one, I wasn't sure what this was going to be, so I said negative 4/3 plus something equals 2/3. So then I figured out it must be thirds on the bottom, and then I was like, well, negative 4 plus what equals 2, and so it ended up being 6/3. That's just 2. So that means my exponent is going to be 2. So this is a difference of squares. So now I've got 1 plus x, or 1 minus x and 1 plus x, and then just to make it even a little harder on you, it wasn't really ready for me to cancel anything out, because, well, up here it's not really ready to cancel anything out. So I had to multiply on the top and bottom by a giant 1. So I just leave the 1, by a giant negative, by negative 1 over negative 1. So I just leave the negative 1 on the top, and on the bottom I kind of like multiplied it in. So like negative 1 times 1 is negative 1 times negative x is positive x. But on the top I just left it as negative 1 because when I multiply it in, it changes this bottom term, and this had a negative 1 on it. It changes this bottom term to x minus 1, and then they cancel, and then you have negative 1 over x plus 1. So that one was a tricky one.